This is a math story about the fundamental counting principle. Feel free to pause it at any time to take notes or do figuring. Ralph T. Mangler must decide what courses to take his first semester at Low Tech. He has narrowed it down to the following: one math course, a PE course, an English course, a philosophy course, and science, of course. How many possible first semester schedules are there for him if the following classes are still open? There are 5 math courses that are open: Math 101, Math 101A, Math 101H, Math 300, and a non-credit course, Math 080. For PE, there are 2 courses, the standard 2 that you have any place, PE 400 and PE 401. For English, naturally, there is only one, English 100. In philosophy, Philosophy 200, 201, 202. And finally, for science, Science 100, Science 101, Science 101, 102, and Science 103. How many possible schedules can he have if any one of them are available, and he will take only one of each one of the types? One way to solve this kind of problem is to draw a tree diagram. So, for instance, he has 5 choices for mathematics, so you would have 5 branches in your tree. Each one of the ends of those branches, he has the choice of 2 for PE. Of course, for fresh person composition, only 1 choice. And if you follow this to its logical conclusion, you get a pretty messy looking picture, but the question would be, how many leaves would there be at the end of the tree finally? And you can see if you follow any one of the branches all the way down to a leaf, you have found one of the schedules, one of the possible schedules. So altogether, there would be 5 times 2 times 1 times 3 times 4. Typically, we rearrange that and write it as 5 factorial. What we've done here is we've used the fundamental counting principle, which is essentially figuring out how many leaves there are in the tree. This is a counter example, and you'll see what I mean. Ralph decided to take underwater basket weaving. There are 50 students in the class. Each had to do a semester project, so since he had no grad students, the professor decided to have them grade each other's projects. If each student grades 1 project, in how many ways can project grading be done? Think about this. Suppose Al Most gets first choice. How many choices does he have? Let's say he picks Bonnie Lass's projects. How many possible choices does the next student have? That actually depends. If Bonnie picks next, she has 49 choices. However, if Carrie Mihom picks next, she can't take Bonnie's because Al has it, and she can't take her own, so only 48 choices. You can try to do a tree diagram for this, but you will see, since we've got different possibilities at the very beginning, we're going to end up with a lot of branches, and it gets messy very quickly. As we proceed, it just keeps getting worse and worse and worse. Try it. The solution to this is something called a derangement, which is a story for another time.